Hi, everybody. Welcome to another Haas Talks Foss. I'm here with Derek Downey. Hi, Derek. How you doing?
Hi, Matt. I'm doing great. How are you?
Good. So, Derek, we wanted to talk a little bit about what you talked about at Percona Live, but before that, there was some exciting news that I saw on the Twitter slash LinkedIn verse. You've just joined Google.
That's great.
Congratulations on the new role.
Thank you.
If many of you don't know Derek, Derek has been around the MySQL space and the open source database space for 10 years. I think I originally interviewed you for Percona like 10 years ago. It's been a
Close to.
long time. Yeah,
Close to. It was about eight
yeah,
years ago, but
yeah,
I was in the MySQL world well before I even dared to apply to Percona. But yeah, it's been a while.
yeah. And you worked at Pythian for a while. You worked at Solar Winds, and now you're at Google. So what are you going to be doing at Google?
Yeah, so I'm working as a developer advocate at Google Cloud, focusing on Google Cloud's database offerings and services. And
So is that
really
like
what
Google SQL? Is that like
so
Google
Cloud SQL.
Cloud SQL? Yeah.
That will be part of it.
Okay.
My initial focus will be on Cloud Spanner, actually.
Oh, very
So
cool.
the big product that Google Cloud has around relational databases, distributed databases. So I'm very excited about that, actually.
Well, yeah, and Spanner is one of those technologies that has, you know, just generated so much innovation in the space. When you talk to,
Yeah.
like Yonkovit, they're like, "Oh, this is Postgres and other things with Google Spanner." You talk with, Cockroach, they say a very similar story. I mean, Spanner is really kind of the granddaddy of all of these technologies.
Yeah, and so I'm really excited about that. I mean, they're solving a thing that has really been hard to solve in like a MySQL database. So this distributed data store, yet still retain a lot of the SQL layer relational aspects that I guess NoSQL databases tried to do away with it for a while. So
Yeah, right. I mean, it's the trade-offs, right? It's the cap theorem. You've got to trade something off in order to get the other two. Um, so
there's an
yeah,
interesting debate about Spanner. Does it destroy the cap theorem? And there's a couple of talks that I was watching recently about the I can't remember his name, but the person who created the cap theorem, developed it, wrote about it, basically saying Spanner does not destroy the cap theorem, and it's basically agreement that Spanner uh, trades off partitioning, right? Like it's just a very low chance that that partition is going to happen. So that's how it kind of avoids that.
well, and I think it's similar with a lot of these other technologies. They're willing to trade off some of the, you know, uh, either the partitioning or like availability even, because they figure that the underlying hardware now or cloud infrastructure is going to be highly redundant anyways. So,
All right.
there's always these things to mitigate, one of those areas, which is always an interesting, um, thing to dig into and to look at. So where do you fall? So do you think that cap theorem has been invalidated now by Spanner?
No, no. I think a lot of it is like we still trade off partitioning, but like you said, we've mitigated the risk of that by being redundant. So
Yeah,
um,
and so if you're listening and you don't know cap theorem, it is the idea that you can get two out of the three big areas, which is consistency, partition tolerance, or availability. And so in any clustered system, you basically pick two out of the three, and then the third one kind of like gets minimized or even eliminated in many cases. And most databases will pick two of the three, and there really
right.
hasn't been any that has crossed all three. So
But anyway, that's what I'm doing around that. So, developer advocate, if you're not familiar with the term, the way I phrase that is, I'm helping users use Spanner. Like if you don't know what Spanner is, and you're just getting started, like I will be helping put content out there to train you on the concepts around it. But also, it's kind of a bridge between the users and uh, the product team, where I'm taking that feedback and going back to the product team and saying, hey, this could be improved, or
Right.
are we missing this feature, or things like
So
that. So it's kind of like that bridge between customers and the product
So you've
team.
really got a dual role then, right? So your role is not only to help educate people and get people to, understand what they can do with it, but also make the product better.
Right,
Yeah.
exactly.
And so, for those who are using Google Spanner, like what are some of the use cases that you've seen early on in your early? I know it's only been like a few weeks now, but Spanner's been around for a while. So what are you seeing as some of those use cases that people are deploying it for?
You know, the I'm not going to be able to speak with any authority on use cases here. Basically, one of the beauties of me becoming a developer advocate for Spanner is I really am net zero, other than a high understanding of, how they're solving distributed SQL. But there was a big demo that they did at Google Next back in 2019, back when things could be in person and things like that,
What in
where it
person? What
was
is this in
ticketing.
person?
Yeah, I don't know. But anyway, the demo was all around like a ticketing system.
Okay.
So a distributed, like you're buying and selling tickets to events all around the world. You only want to sell one ticket. So I mean that's a classic use case of it. I imagine financing would be a good use case of it, because you don't want to. You have potentially Bitcoin, like all these things around the world, and it's like, I'm just kind of spitballing some ideas that, the idea is that you need that consistency, that durability, ACID compliance for a distributed database, a globally distributed database. And so anything, if you're not in that space, then you probably don't need Spanner, you know?
Well, we look forward to seeing what you learn with you. We and seeing
Yes,
what you put out
exactly.
there. It's always fun when you learn technologies together, and if you've got someone who's walking through that journey, it's an awesome thing to kind of walk with them and
Absolutely.
experience what other people would do. If you've been in the space for years, it's very easy for someone in the MySQL space, for instance, like myself or you, to probably overlook some of those things you just inherently know. And so,
Yeah.
what do you mean you didn't do this? Oh, you should have done that. It's coming out.
And I find the questions that come out of sessions like that to be very enlightening, because we're all coming in from our different perspectives and our experiences, and it's like, oh, I didn't think of it that way. So how do I solve that?
Right. Yeah. So, we mentioned, like you talked at Percona Live, and so one of the things we wanted to get you on
Mhm.
to talk about was your topic, which was talking about using Ansible to do, automation around the databases. And, here's the thing. I mean, I know in your new role, you'll probably see this quite a bit, and you probably saw this in your older roles as well. Everybody has a bazillion databases now. It's not just like like when I started, there was like the database, right? Like and I'm dating myself, but oh, the database is down. Everybody knew what the database was, and then, the database is down. Now there isn't the database; it's which one of 10,000 databases. And
Yeah. So that's an interesting like observability problem too. It's not just automation. Sure.
yeah,
But go ahead with your question.
yeah. No. I mean, and this is where it gets, it really puts to the forefront. How do you manage? How do you deploy? How do you ensure that everything is consistent across this, massive realm of databases? Everybody wants their own database, and so you talk about Ansible. Other people use Kubernetes. Other people use Chef, Puppet, for orchestration, Salt, pick whatever, like tool you want. But maybe talk to us a little bit about like what kind of brought you to Ansible and what you see in this space where, geez, everything is just kind of exploding in terms of the size and amount of databases.
Yeah, it's a great question. Like you said, automation means a lot of different things to a lot of different people. There's a lot of different tools out there to solve a problem. Um, my talk on Ansible was as an example of solving some problems around the databases with this particular tool. Um, I really got into Ansible when I first started at Pythian a couple months in, there was a project that I was working on that really had this customer with about 20 databases distributed like in a 3-tier replication architecture across 3 different data centers. And we pointed out, hey, there's some issues with your architecture. You might want to kind of reduce that a little bit for DR and reasons. And so they said, sure, let's do that. So it was my job to write the run book basically to squash this tier of 20 databases into a 2-tier system. So I did that. I wrote the run book. It was along the lines of log into the node, stop replication, let it catch up, repoint to the primary, whatever, the new primary. At that time, it was binary log positions. So you have to figure out the right positioning, right? So of a completely different parent. So anyway, it was going to take let's say about almost 2 hours to do this entire maintenance, and that is with being cautious and hopefully not making any mistakes along the way and pointing it to the wrong server and having to rebuild and all that fun stuff. My manager came in. Now this was when I first started at Pythian. This was 2013 time period. He's like, okay, I'm going to write this in Ansible, and Ansible had been out for about a year maybe at the time. So this is Ansible 1.2 or whatnot. So really fresh technology. I'm like, oh, sure, whatever. He writes this thing, completes the maintenance in 5 minutes. I'm like, oh, that's awesome.
Yeah.
So that's when I really had like the light bulb go off that there is a better way to do some of these tasks than manually, and runbooks even. Runbooks get you somewhere there, and they're all trying to solve a specific need of mitigating risk during a maintenance, right? But you're still typing and cutting and pasting and all this stuff. Whereas if you can write some automation around it then and have a good script, then you cut out the need for or the potential for even those copy and paste errors. So that's when I really started developing a love for automation. And yeah, Ansible was if you skip the whole bash scripting, custom scripts, and get like into a framework, Ansible was my first exposure to that.
And this is really,
world.
For this use case that you're talking about here, this isn't necessarily about the herd mentality. It's about saving time and efficiency and reducing errors.
And safety. Yes, absolutely. And that's what I think automation on the data layer is all about, is like saving time, providing a little bit of ROI for your time so that you can get back to the real critical tasks, and then reducing errors, because the data environment is probably your most critical environment that you don't want mistakes on.
Very cool.
So anyway, so that I started with Ansible. I since have expanded into, like you said, containers and somewhat Kubernetes more recently, but Terraform for sure. So my presentation was really like, if you're not automating, then why not? And here are some practical tips to get started in the database management realm, if that's where you're coming from. And then I ended with some cautions on, hey, just because you are now starting with Ansible, there are so many other tools out there, and you need to be evaluating, do I really need to be automating this? Is it worth the investment? And also how to avoid...
Oh, I was going to say, so really, there isn't this magic automation button that just makes everything better. You have to think about it, because there is the cost of building the automation. And so, is the cost worth it? Mm-hmm. Is it justifiable?
Exactly.
That's an important aspect of that. I think that, that's an often overlooked one, because I think it's so easy to get caught up in the swing of, I'm just going to make this automatically happen without me, so I don't even need to worry about this. I can go spend my time on more, interesting things. And then a year later, you still haven't completely finished your automation because you're trying to perfect it or something, and I think that, as a tool, it's an important step in the right direction. But I think people often, use it as that silver magic bullet to fix everything.
So I'm going to propose a way to address that.
Oh my gosh!
On this podcast, but Like I have this kind of the way I think about how do I prioritize what task I do is I kind of look at three different components. The first one is frequency. How often is the task run? Um, if you're running it all the time, then you're probably going to want to get more of a return on your investment for automating it. Which ties into the second one, which is complexity. Is it really hard to automate? Because if it's really hard to automate, then you're going to be spending a lot more time developing, the edge cases and things like that. So you need to kind of rate it on those two spectrums. And then the third one is criticality, which is this a super critical component of managing a database? If I don't do this task, will it come back to bite me later? And so if you can rate those, I kind of, on a matrix, so it takes a little bit of, forethought and evaluation on your part to say, am I really going to get my bang for buck out of automating this particular task? Is it going to be too much? And then you can look at it and say, you know what, I'm not going to, but I'm going to do partial automation. Like there are pieces of this that I can automate with something like Ansible that can reduce errors, but the rest of it is still something that a human has to
Yeah,
participate
and
in.
I think that that's important to be able to evaluate and to build that out. I think the other dark, seedy underbelly of automation, if you will, is once you've automated it once doesn't mean it's going to continue to work. And I think that's one of the things that is a fallacy some people get into. I'm just going to automate this. I'm going to just stick it out there, and then I don't got to ever worry about it again. And the fact of the matter is, as upgrades happen, as changes happen to environment, underlying software, the stacks, new security patches, all of that has the potential to cause other issues. And this is especially true, when you look at like a CI/CD pipeline, because CI/CD pipeline is really just automation of that, release and deploy. And you see that so many major outages happen because somebody introduces some underlying code, it gets automated and propagated to 10,000 machines. Now all of a sudden you have to roll back 10,000 machines, and that is a problem that I see continually crop up and continually persist. And it doesn't matter how many like layers of redundancy or availability you have, if you're going to automatically deploy bad code or misconfigurations across all of your nodes. And
Absolutely. I touched on this a little bit in my presentation in the cautions aspect because I think you're absolutely right. The idea of I don't know complacency. Like once it's automated, it's good, and I don't have to worry about maintaining it. And then you go to run your quarterly DR script that the whole thing has changed in the last quarter, and then all of a sudden it doesn't work, right? So I really like the idea of this like continual testing in production, chaos engineering. These concepts, like it's really hard to do to get your mind around it in your critical data environment because it's like I can't test this in production because I might bring down an outage, right?
well,
But you have to because otherwise you won't know what happens in production when you run it.
so this is where it's interesting because I think the theory outpaces the ability to implement those technologies, right? So, or those ideas. Like, so you talk about chaos engineering, you talk about testing in production. This is great if you can get away with it. Let's bring down a random node today. Yay! Let's see. Let's make sure that everything still works or what have you. The problem is most applications aren't designed for that, right? They're not designed for that level of fault tolerance. And oh well, you mentioned earlier that sometimes failovers take time, right? And I think that during the automation process, as you start to automate things, certain automations, like it could take 10 minutes for a new node to be built up and created and move things over. That's an unacceptable amount of time for most applications.
Yep.
And so that means that, like, unless your application is built to say, oh, this resource is out, now I'm going to go do this, or you're using something that will automatically spin up additional nodes, or has that elastic capacity to survive that, it becomes problematic. And a lot of times people end up with a lot of redundancy on the application side and very limited on the database side. They rely on a replica, or group replication or something like that.
Yep. Yep. I think you're absolutely right. Like, if you're listening to these theories and concepts of how some of the big companies have solved like chaos engineering, like Netflix, or all these different aspects of managing databases, they're solving for really big problems that you're probably not going to. But what comes out of these discussions as Netflix engineers and Facebook engineers and all these big companies start sharing their knowledge, is new applications spin up with a foundation that's a little bit better than what the old applications have been spun up with, right? And so overall, over time, you start to get a better foundation for architectures and data layers and stuff like that.
Yeah, I mean, I think you continually want to level up, and leveling up those applications is important. It's just that there's so much legacy out there. A lot of times people will hear like, oh yeah, we should totally do some chaos engineering. We should totally run a continuous deployment, continuous test environment, but then they try to apply it to a inherently fragile or legacy pipeline, and it just destroys it.
Yeah.
And then they run away.
Don't start with it in production until you've tested it somewhere.
Yes.
And I touched on that with the Ansible automation course as well, or the presentation, which was, hey, if this is your first venture into automating with Ansible, you're not going to be running it against production until you vetted it in a development environment, a staging environment, and you've built some confidence in what you've developed that it's going to work. You don't want to just push button deploy in production if you've never done it before.
Yeah, I mean, testing is so critical in all of this, and making sure that it does work in the right environment, in the right context. And even with testing, you're still going to run into those issues, unfortunately.
For sure.
And you have to realize that. And that's where, it requires you to think about how this is deployed, how this is built. And it's similar, looping all the way back to Spanner. As you build, an application with Spanner, or, any of these distributed databases that are out there, it does change how you develop your application and how you think about it. It's not always just that lift and shift, like, oh, we're just running a single node, of everything, and now all of a sudden we're going to go to this, multi-layered, database, multi-layered application stack. We're going to add the Kubernetes ferry or whatever to, this, and it's just going to magically just scale.
It just works. Yeah. Nothing breaks.
Yeah. There is no magic Kubernetes ferry, at least none that I've met yet. Maybe there is. That would be a cool.
No, exactly.
Right? The Kubernetes ferry's here to solve all your problems. Woohoo! Pixie dust.
Woohoo! Then we're all out of a job, and we can go sip Mai Tais on a beach. So.
Right. There you go. It's the automation will replace all humans, right? So Derek, where do you see things, kind of evolving? You were able to attend Percona Live. You were able to, you've been in the ecosystem, in the database ecosystem for a while. What do you think's next? What do you think is, the next thing that's kind of cropping up that you're looking at going like, that looks interesting, or that's where I think the next really interesting discussions or technology is going to come from?
I mean, the thing that stood out to me from Percona Live this year was the amount of Kubernetes sessions that there were. So you've mentioned it a few times. Data on Kubernetes. There's a really good community around it. I think that you've done a podcast with, or a talk with Bart on data on Kubernetes and how do you solve that problem. The trend to me is like, hey, Kubernetes may be the standard de facto way to manage infrastructure soon. And it has been for a little bit for applications, perhaps. Data is just and state is starting to creep up on that, where it's actually feasible to do that. I think that's, if you're talking about in the next 2-3 years, we're going to get some really interesting stuff out of running databases on Kubernetes. Um, I felt that way for a while. I first started playing with Docker when like 2015, 14 timeframe. And I was like, oh, this is really great for dev testing, right? But there's no way that this is good enough to run a database in production. But as technology does, you solve the use case and then that you're going for, and then you start tackling the next one and the next one. And so I think Kubernetes is doing that with databases. If you're not thinking of running some cloud vendors database as a service for your underlying data layer.
Yeah, I mean, I look at this as almost like the drive to not have to even think about databases or the infrastructure. I mean, from an application perspective, it's the push button desire that I don't really care what database technology I'm using, as long as I have an interface and I know it's going to be up and secure. I think it's becoming less and less that developers
securities maybe.
well, like but I mean, like let's be honest. From a development perspective, if you've got the ability to access and store data, retrieve it quickly, get what you need, you don't want to worry about the HA, the backups, the security side of things. You just want it handled behind the scenes. And in a lot of those cases, you don't even care about whether it's a Mongo or a MySQL or a Postgres or a Cassandra, as long as you're able to access the data easily and quickly. It becomes less important for you to understand that underlying infrastructure. Now, for those who have to maintain the infrastructure, that's a whole different question. But like when we talk about like from a developer perspective, that like desire to have like almost like a zero database is a real thing, I think. And that's where I think is from a Kubernetes perspective, everyone wants their own database and you never know which database it's going to be. And so having some technology to allow you to easily add, remove the right databases makes sense from an infrastructure standpoint, because you just don't know if the same things you need today will be the same things you need tomorrow.
Yeah, and my caution on that whole concept of developers want something push button, easy to deploy, is that usually when you try to get something generic enough that can meet all needs, complexity creeps in, and you start to get really inefficient like operations. My example of this is when I first started off as a PHP developer, all of the developers or all the designers were using an application called Dreamweaver. What you see is what you get, like website developer type thing. If you looked at the code that was developed by Dreamweaver, it was the most ugly, inefficient use of tables within tables within tables. And so my first project there was to say, hey, here's your design in Dreamweaver. Here's what I did with divs and CSS and all this stuff. The files are about, I don't know, I think I cut it down by 30% of the file size. By the way, that translates into load time for your websites. So all that to say is like you can get complexity that starts to look inefficient with your infrastructure, and either it's going to go start performing slower, or you got to get really good infrastructure people to understand how to mitigate that or improve that complexity.
I mean, that whole complexity versus speed has been around forever. I mean, think about ORMs. So like largely ORMs are there to hide the complexity of the database for you, and they generally make some pretty weird decisions around like joins and like what data is retrieved and other things, which has often been the bane of most DBA's existence, because they're looking at these performance problems going, who would write that query? Like, what were you thinking? And the developer goes, I wasn't thinking. The tool just generated it.
And the developers still go towards the ORMs. Like, they're still a thing. They're still highly popular.
Because I think it's that abstraction layer. I really do, because databases are a pain in the rear and they're not cool.
No.
Like, let's be honest. Databases aren't really that cool.
And so it's probably ORMs do a really good job for the generic use case that, like, let's say 80% use case, just to use some famous numbers. There's 20% of that you may not be in, so you may not have to think about it until you are, and then you're in this mess of infrastructure, and how do you solve that? So I think that's how, like, middleware crops up, like proxy SQL, to kind of bridge between translating what the ORM is doing to something that's more useful for and better for the database.
Cool. So that's actually interesting. So I have not seen anyone do that. So have you seen people actually use proxy SQL or, like, a proxy server to translate the crappy ORM code into something that actually is performant? Mm-hmm. Like, I mean, I know I've seen, like query rewrites, but I have not seen it specific to an ORM.
It's not so much specific to an ORM. Like, I consulted with Proxy SQL, contracted with them for a period of time, and it was more, every one was different, but you started to get a sense of which ORMs a client was using and saying, oh, you need to make sure that you handle this case. It's not ORM specific. You need to do an evaluation of your queries to do the rewriting. But if you've worked with it across a wide spectrum, you can start to publish, which has not happened. Like, I agree with you that there's no, like, common use cases of these rewrites if you're using Ruby on Rails, or these rewrites if you're using Django or whatever. SQL Alchemy is what I'm thinking of. But that's why it exists, is because the application is not going to rewrite the queries, whether the application is custom or the application is an ORM. So something has to translate that. And sometimes it works and sometimes it doesn't.
Yeah. Well, Derek, thanks for sitting down with me today. I appreciate it. And if you haven't checked out Derek's talk at Percona Live, it should be up on YouTube or on our website. Derek also has his own blog. You want to plug your blog and your channels there, Derek?
Yeah, absolutely. So my blog is Distributed DBA, where I basically publish a weekly blog post, sometimes all the time in video, and then a transcript of that so that you can learn differently on database topics. But also remote work, because I've worked remotely for my whole career. So I like to plug in every now and then, like, tips on how to work remotely, because we're doing that. So that's my blog, distributeddba.com. And yeah, I'm at Google Cloud. Now you can best find me on Twitter. My handle is Derek _ Downey. And that's where I can most readily be reached.
All right, great. So, Derek, thanks for joining us today. We appreciate it, and we look forward to learning all about Spanner with you over the next, few months.
Thanks for having me, Matt.
Wow, what a great episode that was. We really appreciate you coming and checking it out. We hope that you love open source as much as we do. If you like this video, go ahead and subscribe to us on the YouTube channel. Follow us on Facebook, Twitter, Instagram, and LinkedIn. And of course, tune in to next week's episode. We really appreciate you coming and talking open source with us.